All right, so we currently do not have any rules, within the local.rules file. Now, let's start off by creating a few basic ones, right? Now, in order to create one, we're going to say sudo vim, and you can use any text editor that you're comfortable with as long as it has the permissions to make changes or to write changes to these particular files. So etc snort, and we are going to go under rules, and the name is local.rules. As you can see, it's empty, so this file intentionally does not come with signatures. Put your local additions here. Fantastic. So let's start off with a few examples. All right, so let's say we wanted to detect any ICMP pings, right? And I'll actually talk you through how to use Snorpy in a second. But the syntax is very simple. So you start off by specifying, if we take a look at Snorpy, the action. So with Snort, we can alert, we can essentially, send an alert to the terminal. We can log that particular packet or network activity. We can pass the packet. This is in the case of the intrusion prevention system. Dropping and rejecting are also part of the intrusion the intrusion prevention system or functionality of Snort. In our case, we're primarily focused on alerts and logs. And in our case, in pretty much many or most cases, we want to use the alert option. So I'll say alert. So that's what we're essentially saying here is for any of the following traffic that I specify, I need you, Snort, to actually, provide me with an alert whenever a ping is made. So in order to do this, we're going to say alert ICMP, because pings essentially send ICMP requests from any network and any port. And then we say that comes into our home network. Remember the home network variable that we had configured within the Snort configuration file. So we're essentially saying that subnet, or what we're saying is I want you to generate an alert for any ICMP traffic that comes from any external address, with any external port into our home network subnet. And then you specify the port. In our case, we'll say any, because pings are really not targeted towards any specific port. And then we specify, in the case of an alert, we specify a message that we would like to display. So in this case, we can say message, and I'm going to say ICMP ping detected, and that's what's going to be displayed to the relevant user. That's essentially monitoring the actual intrusions or the traffic. We then need to specify a signature ID. This can be whatever you want it to be. It's generally recommended to have this to essentially provide a unique value so that it doesn't conflict with the other signature IDs. So in this case, we can just say signature ID is going to be maybe, we can say 10,001, and we then want to use a semicolon, and you can then specify revisions for specific for specific rules. So in this case, we can say this is a revision 1, and we then close the brackets there. So that is a Snort rule. All right, so we have created a Snort rule. Fantastic. And you can keep on adding other rules on the next line. So let's write and quit. All right. And what we are going to do now is we are going to run Snort. Now, in order to run Snort, you need to understand a few options, right? So whenever you're running Snort, the most important option is the alert mode, right? So the alert mode allows you to specify what types of, the actual format of alerts. So, for example, the fast alert mode writes alerts to the default alert file in the single line syslog style alert message. Full writes the alert to the alert file with the full decoded header as well as the alert message. And in our case, we're not really going to be logging the alerts. By default, we're going to be logging the traffic, but we can essentially specify this to either be fast mode, but in our case, we're going to say log all the alerts onto the console. The other option we need to use that we're going to be using is the L option, which allows us, if I can find it here, there we are. So this is the log directory. So this will set the output logging directory to log directory. we'll be using that, and we'll be specifying that we want to save all our logs under var log snort. This is very important because what's the point of performing network intrusion detection if you're not logging all the relevant alerts for later analysis or for implementation or integration into a tool or a visualization tool like Snort. The other option that we're going to be using, of course, is going to be the interface option. We will be specifying our interface. We then need to specify the queue option, which I believe in this case is quite important. We want Snort to run quietly. I don't want it to display all the diagnostic information in regards to the rules loaded, etc. So MNOPQ, there we are, quiet operation, don't display the banner, and initialization information. If you are running it as an intrusion prevention system, then you never want to use the capital Q option, because that will disable, or sorry, that will enable inline mode. So yes, when you are running it as an IDS IPS, then you need to use the Q option to run it in inline mode. In our case, we're not doing that. All right, so to run Snort, there's a few arguments we need to specify. So we'll say sudo snort. We're going to run it in the quiet mode. The log file is, or the log directory is under var log under snort, and what we can then specify now is our interface. So enp 0s3, in your case it's going to be different, so do take note of that. And then the actual alert mode is going to be console, because we're displaying it to ourselves, we're not yet logging them. And then we need to specify the configuration file that we're going to use. If you've created a custom one, then this is the best time to add it here. So we're going to say cd etc snort and snort.conf, and we can hit enter. Now if it doesn't provide you with any output or any errors, then that means it's working. So let us actually test this. Let's see if this is indeed working. So I'm just going to open up a command prompt here, and there we are. I'm just going to clear that out, sorry, CLS, and I'm just going to perform a ping, right? Now this device is part of the network, is part of the actual local network. So I can ping a particular device that is within the network. But before I do that, I actually want to fire up the Linux virtual machine. That is the Metasploitable 2 virtual machine that is going to run within the network. We're then going to ping it with our Kali Linux VM as well. And you'll actually see the traffic here. So let me just start the VMs and we can resume from that point. All right, so I've started all the VMs, including the Kali Linux VM. And what I'm going to do is I'm going to run a ping on the Metasploitable 2 server. So I'm going to say ping, and the IP address in my case of the Metasploitable 2 server is on 192.168.2.157. All right, so I'm going to hit enter. And now if we switch back to the Ubuntu VM running Snort, we should see these alerts. So back on the Ubuntu VM running Snort, you can actually see the pings being detected based on the rule that we created, which is fantastic. And I'm just going to terminate that particular ping on the Kali Linux system. So I'll just Control C that, and let me switch back over to the Ubuntu VM. And you can now see that the alerts have stopped being produced, which proves that it is indeed working. So the format is very simple. You have date time, and then of course you have the signature ID, then of course the message that we specified. So ICMP ping detected. We can also specify a priority, the actual protocol, the address it came from, and the address it went to. So this is the IP of the Metasploitable 2 virtual machine. This is the IP address of my Kali Linux virtual machine where I performed the ping from. Fantastic. So that's how to create a very simple rule. I really like using this example because it allows me to showcase a few important techniques. All right, now what I'm going to do now is let's write another rule for SSH connections, right? Because that can be quite important to monitor on a network. So I'm going to go back and modify the local.rules file, and I'm going to create another one. So I'm going to say alert. And in this case, because SSH runs on TCP, I'm going to say TCP from any connection on any port. We want to essentially generate an alert whenever it comes into the home network subnet on port 22. Remember, we need to specify the appropriate port for SSH because otherwise the rule will not work. We then create a message. And the message can be anything. In this case, we can say SSH authentication, you know, and because we can't, at this point, we're not really, you know, going deep into determining whether this is a connection, a successful authentication attempt or a failed one. We're just going to say SSH authentication, and we can just say attempt, right? Just to give it a bit of nuance. And then for the signature ID, we're going to make sure it doesn't conflict with our previous one. So we'll say, you know, 10,002, and we'll just say revision is 1, and we can close that up. And now I'm going to write in quit. And if I go back onto my Kali Linux system, we're going to try and authenticate with Metasploitable 2 via SSH, because that Metasploitable 2 system has an SSH server running on it. So I'll just switch back to Kali here in a second. There we go. So I'll say SSH, the username is MSF admin, and I'm going to say 192.168.2.157 and MSF admin. There we are. So we authenticate successfully. So what we're trying to do here is try and see from the perspective of the defender what this network activity looks like, and if they have written rules for it, then they should be able to detect what's being done on the network. That's the essence of intrusion detection and network traffic analysis, right? In the case of network intrusion detection, we're essentially fine-tuning our network traffic analysis to identify and automate the process of identifying intrusions or threats. So let me switch back over into my into the actual Ubuntu VM, and I had actually not started Up Snort. So let me just do that again, and I'll just do it again, and we can run that authentication attempt once more. So I'll just exit and I'll run it again, and I'll just provide the password there, and I'll switch back over, and you can see we get the SSH authentication attempt alerts. Fantastic. So you can now start to see how cool this is. And of course, this will also work for all the other rules that we specified. So for example, I can, you know, I can actually ping. So if I say ping 192.168.2.157, you can see that that ping is detected. So, you know, really robust network intrusion detection system. And, you know, the power of your network intrusion detection system will be based upon your rules. Now, as I said, the reason why I disabled the other ones is because I wanted to showcase how you can write your own. So let's explore how to use the Snorpy tool, right? So the Snorpy tool is essentially a graphical user interface that allows you to simplify the process of creating a rule. So it's really very simple. You specify whether it's an alert or whether you want to log it, etc. You then specify the protocol, right? So, you know, we can say TCP. In this case, we can say any connection from any address into our home network. So we'll specify the variable, so home network. So you can see it provides you with the fields, and you can easily specify or create your rule. And at the bottom, you can actually copy it and paste it within your local.rules file. In this case, let's see if we can create a rule for FTP. So FTP is on port 21, signature ID. We'll give that 10,003, revision number 1. We can also specify the rule message here. So we can say, in this case, FTP authentication attempt, right? And we can also limit the actual, or we can also specify what IP we're interested in. So instead of looking for all FTP connections coming into the actual network, we can specify only alert us when there's an FTP connection made to a specific IP within our network. So in this case, we can specify the IP address of the actual Metasploitable 2 virtual machine FTP authentication attempt on MS2, right? And we can then specify additional options if we require them. In this case, I'm just going to copy that there. And we'll go back here and we'll just terminate Snort. And we'll go into our rules here. And I'll say insert, paste that in there. Let me just make sure that that is displayed correctly. And there aren't any issues. Yep, that looks good. So Snorpy is really useful in this way. Write and quit, and we'll start up Snort again. And I'm just going to make, or, you know, we can actually authenticate with with Kali Linux, with MS2 with Kali Linux. So I'll say exit, FTP 192.168.2.157 on port 21. Hit enter. MSF admin, MSF admin there. There we go, etc. All right, so let me switch back over. There we are. You can see that in this case, when we started it, it looks like there was an SSH authentication attempt. I believe that is the case. That was on port 22. I'm not really sure why that was logged, but hey ho. As you can see, it actually logged the actual FTP authentication attempt on the Metasploitable 2 system. So from this example or exercise, you can start to get a feel and understanding as to how robust Snort rules can be. And this is obviously made evident by the, by the really awesome rules that are written by the community and by Snort themselves. All right, so again, I would recommend taking a look at Snorpy if you want to learn how to write your own rules. Another great resource to learn how to write your own rules is to take a look at the rules written by the community. So let's take a look at a few examples. Now, the first thing we would need to do, of course, is to disable or enable the rules we had disabled within the configuration file. So I'll just modify that file now. And we are, sorry, that is still the rules file. We want to modify the snort.conf file. And we want to head over to the lines that we had commented, right? Because those rules are very, very important. So we want to uncomment the ones we had commented earlier on. So in order to do this with Vim, we're just going to specify the start line, which was 578 and 696. For the end line, and we are then going to say the start of the line that begins with a hash or a pound, just get rid of that. Hit enter. That gets rid of the comment for the rules that we had initially commented, so it'll still maintain the initial comments that were specified by default. So let's write and quit, and let's take a look at the community rules offered by Snort. So if you head over into your browser on snort.org, you can actually download rules, right? There we are. And right over here, as you can see, for Snort version 3, you have the ability to download those rules. And for Snort version 2.9, you can download those rules there. So you can click on that, and you can open up your downloads directory. And you can extract that. Ideally, it's recommended to extract that within the actual etc snort rules directory. But I'll just show you an example as to how you can learn how to write really complex rules and the options afforded to you. Right, so I'll extract this here. This will contain a snort.configuration file based on the rules, on these particular community rules. So if you take a look there, you can see that it still utilizes the local.rules file. And then, of course, it has all of these other rules here. And if we take a look at them closely, I think we would need to include them. But what we can do is we can identify the rules that we're looking for as an example. In this case, they're going to be under community.rules. There we are. So this is essentially a set of rules that allows you to detect exploits, intrusions for specific CVEs, malware network activity. So, for example, in this case, you can see that alert, for TCP connections coming from an external network into the home network subnet on port 7597, then that is logged as a malware backdoor QAZ worm client login success. And you can also specify the TCP, the actual TCP flow and the actual state. I'll get to that with Snorpy in a second. But one really cool example I can showcase here is the Eternal Blue attack, right? So Eternal Blue, I can search for that alert here. And what I'll do here is let me just open up my preferences so you can actually see it. There we are. So this is the Eternal Blue alert. So Eternal Blue is a Windows exploit or vulnerability within the Windows SMB version 1 that allows you to perform remote code execution. So I can spin up a Windows 7 virtual machine and we can try and exploit it with Metasploit from the Kali Linux system, and we can add this rule to our custom rule or to the local.rules file, and you'll be able to tell that Snort will be able to identify that as that exploitation process as an intrusion or malicious. Now, one of the great things with Snort rules is they allow you to also specify these a reference point, so you can specify the CVE code as well as the URL where you can actually read more about a specific vulnerability. So what I'll do is I'll copy this and we'll modify the actual local.rules file. I'll put it in there. As I said, you can actually copy that community.rules file into the actual Etsy Snort rules directory and load those rules as well. But I typically like loading the ones that I'm interested in, especially if you're learning. This is really a really cool way. So we can put it in there. The only thing you need to make sure you do is make sure that the signature is unique, or the signature ID, right? And that looks fine. So you can see what's happening here is we're saying, what we're telling Snort to do is alert us if there's any TCP connection coming from any network into our home network that connects to any device on our home network on port 445, whereby the flow is, the actual flow is, you can see, to the server established. So that's the TCP state. And the content, this is where you would specify the signature. So based on the content contained within a packet that is used to perform the Eternal Blue exploit, this is where you specify the signature. So in this case, you can see it's it looks like it's hexadecimal, and then of course you have the byte extract there, etc., etc. We're not going to be exploring how to write complex rules, based on specific exploit signatures, but most of them have already been written for you, so you can actually test them out on your network. Another good example of this is, let's see if we can identify whether the latest vulnerability log4j, there we go. So you can see an alert has been made for log4j, and you can now start to see the power of Snort and the actual Snort rules, because if you use the latest version of this community.rules file, then that means that you're up to date with the latest vulnerabilities and you'll be able to detect them as they occur on your network, which is absolutely fantastic. So let's just use this simple example. So I'm going to write and quit, right? And we can actually start it up. So we're going to start up Snort here, and I'll hit enter. So I'm going to fire up the Windows 7 virtual machine for the purpose of this demonstration. And I'll then switch over to Kali. We can exploit the vulnerability and see whether it's logged right over here on our console. So let me just fire up the VM. All right, so we have Snort running. I've started up the Windows VM. I know the IP address, and I'm currently on the Kali Linux virtual machine, and we're going to be utilizing a popular exploitation framework called Metasploit that already contains a pre-built exploitation module that allows me to exploit the Eternal Blue vulnerability on affected versions of Windows 7 being one of them. So, in this scenario, just assume that you had a Windows 7 system on your network and it was vulnerable to Eternal Blue, and, an attacker had gained access, and, you would be able to essentially identify that this attack was being performed. So I'll just say use that module here. So I'll say use, paste that in there. And for this module, the only option I need to set is the target IP. So this is the IP of the Windows VM. So the IP address is 192.168.2.35, and I can then hit exploit, right? And this should provide me with elevated privileges on the Windows system if successful. So based on the way this exploit works, I should be able to detect this attack as a defender by taking a look at the alerts generated by Snort based on the rule that we created, right? And if we had implemented or loaded the entire set of rules within the community.rules file, then this would be the case anyway. But again, I just wanted to showcase how you can also, identify specific CVEs and vulnerabilities and exploits, right? So let me just switch over back into the Ubuntu VM. And there we are. You can actually see it live. So there we are. We have, based on the other rules that we had enabled, we have a few other alerts here. So you can see bad traffic, potentially bad traffic. And then, of course, we have that rule here. The Eternal Blue alert is generated. So OS, Microsoft Windows, SMB, remote code, execution attempt, classification, attempted administrator privilege gain, priority 1, where the attack came from, and it's the port it came from, and the actual IP address of the Windows system on port 445. And there are going to be multiple alerts because the exploit sends multiple packets And of course, we have these additional ones. So you can see in order for this to work, because this exploit targets SMB, you can see there we are. We have a NetBIOS alert that tells us that an SMB IPC share was accessed by the following IP. So you can actually see how useful this is. So I'm just going to terminate the exploit, and we can take a look at the final section of what I wanted to cover. All right, so the final section that I wanted to highlight was logging and where all of this information is being saved. So if you, let me just terminate Snort here. If you take a look at the command that we used to run Snort, you can see that all logging was, all the logs were saved under var log Snort, right? However, the actual alerts were displayed on the console. So the only thing that was logged was the traffic, which is very important to understand. So let's open up my file browser here. And if I go into the var log directory, so var log, and we go into Snort, we'll be able to see some interesting files. So these are all the log files that were created by Snort. And these are essentially this is essentially the raw packet capture on the network. So this doesn't have any alerts attached to it. And these can be accessed with Wireshark. Now, in order to access these log files, you need to run Wireshark as root, because these are owned by the root user. So we'll say sudo Wireshark, and I'll show you that, you know, Snort really is extremely powerful. So I'll say file open, and I'll go to my computer, and I'll say var log, and we'll head over into Snort, and we'll open up the latest one that contained the actual Windows SMB traffic. So I'll say open, and there we are. So all the packets were captured directly or immediately from the actual SMB exploit, and you can see you know, all that traffic was captured. So all the packets have been captured. That's not a problem. I want to cover how to log the actual alerts, right? And any other type of either alerts or, you know, if you want to log all alerts, because this, the actual alerts are pretty much the most important piece of information. And if you're not logging them, you should be. So in order to log them, what you need to do is we'll use the same format where we specify quiet mode. We're logging into the following directly under the following directory. However, for the actual let me just show you this right now. So man snort, for the actual alert mode, we are going to be using either fast, full, or none. In the case of fast, this will write the alert to the default alert file in a single line syslog style alert message. That is the preferred format if you're going to be using these logs or importing them into tools like Splunk. So in order to do that, we're going to say, instead of console, we're going to say fast as an example, right? So let me just type that in here, and I'll hit enter. And let me see if I can generate some traffic. So let me just generate some traffic. All right, so I've generated some traffic, and you might be thinking to yourself, what on earth is happening? You've generated traffic, or, you know, you've performed a few pings and you've connected to the FTP server on the Metasploitable 2 virtual machine. Why isn't anything being displayed here? Well, that's because we specified to Snort that, hey, I want you to log all alerts under the following, using the actual alert method. And of course, this is the alert mode. In this case, we specified the alert mode as fast, which is the preferred format, under the var log snort directory. So we were already in that directory, and we can see it right over here. So it's generated a log file called alert. So if we open this up, there we are. We get the actual traffic that I had essentially generated, where I performed a few pings based on the rules that I'd actually created. We had an FTP authentication attempt and some potentially bad traffic right over there. So now at this point, you know, we can utilize this format, this logging format, to essentially import this into tools like Splunk. So again, once you've got all of these logs, they can be analyzed, you know, on this system, or as I said, you can configure a log forwarder to essentially have them dynamically loaded, have the latest logs or alerts dynamically loaded onto a tool like Splunk for analysis. And at that point, then you'd essentially be able to know what was happening on your network in regards to attacks and intrusions directly from Splunk, which is absolutely fantastic. So that is going to be it in regards to what I wanted to cover. We've covered quite a lot. Hopefully by this point you should know how to get Snort installed, how to customize and configure it, how to create your own rules, how to load in community rules, how to write rules, and of course how to log the actual alerts that you've captured, as well as the packets that you are capturing. With that being said, let me just switch back over to the slides. All right, so as a parting note, all the links and resources used in this video will be added to the description section of this video, so you can check them out. You'll also be provided with access to the slides as a reference, so that you can actually navigate through this video. If you have any questions or suggestions, leave them in the comments section, or you can reach out to me and the HackerSploit community on our Discord server. The link to that is also in the description. In the next video, we're going to be taking a look at threat detection with Wazoo. With that being said, I will be seeing you in the next video. I just want to take a couple of moments to thank our Patreons. Thank you, Michael Hubbard, Dustin Umpress, Jerry Speds, Doozy, Sid Saab, Ryan Carr, Shamir Douglas, Jojo Bibi, Palangos, Kushkev, RS, Nino Buikov, and David Bricker. You guys are really awesome. Thank you very much for supporting us, and you guys make these types of videos possible. So we really appreciate it, and we look forward to producing even more high quality content.